The Souza Project. One day, Mr. Souza was out driving his car and not paying attention to the road. As he approached a hairpin turn, Mr. Chuckrin was standing at the edge of a cliff, looking over and gazing upon a nice pile of turkey manure at Mr. Daigle's farm. By the time Souza realized he was in trouble, it was too late. He slammed on the brakes of his car and skidded over off the road and straight into Mr. Chuckrin's Jeep. Both cars flew off the cliff into the pile of manure, and thankfully nothing was injured and no one was hurt. Aware that Souza was speeding, however, Mr. Chuckrin figured he could get some money out of this case and knew that he wanted to sue Mr. Souza. To prove Souza was actually speeding, he called up his trusty physics whizzes, Cam and Nick, to help him figure out how fast Mr. Souza was actually going.
From the crash site, these are the things that we know. Mr. Truckman was driving a '98 green Jeep with a mass of 1,621 kilograms, while Mr. Souza was driving a 2002 Toyota Corolla with a mass of 1,095 kilograms. Mr. Souza's Corolla was approximately 4.315 meters in length. We also know that the coefficient of kinetic friction between Mr. Souza's skidding tires and a dry road is 0.7. And we also know that the speed limit for a hairpin turn should be no more than 20 miles per hour.
To figure out the actual measurements, Mr. Chuckrin set us up with a model mock car crash of the crime scene. The model car that Chuckrin had out was 11.3 centimeters in length, while the actual car Souza was driving was 4.315 meters in length. To figure out a scale for the whole entire model, we divided Souza's actual car length by the length of the model car shown. We did 4.315 meters divided by 11.3 centimeters and came up with 0.381858400708 meters per centimeter to be the scale. The height of the cliff on the model was 91.2 centimeters. After multiplied by the scale, we found out that the height was actually 34.825486 meters. The range the car traveled on the model was 36.5 centimeters. After multiplying it by the scale, we figured out that the cars actually traveled 13.9378319 meters. The skid mark of the model was 15.5 centimeters. After multiplying it by the scale, we found the actual skid mark length to be 5.9188053 meters.
Now we have to figure out the time of flight between the cars going off the cliff and their collision on the ground. We know that the initial velocity, thanks to pirate view, is always 0 meters per second. We know from the scale that the height of the cliff is 34.825886 meters. As always, the acceleration due to gravity is negative 9.8 meters per second squared. Using the second kinematic, which is y equals by naught t plus half at squared, thanks to by naught equaling 0, we simplified the equation to be y equals half at squared. We multiplied by t, then divided by a, took the square root of that to find that the time is equal to the square root of 2y over a. Once we plugged in our numbers, we realized that the time of flight was 2.6659411 seconds.
After finding the time, we had to find the velocity that the two cars traveled off the cliff. To do this, we used the horizontal projectile motion equation x equals vxt. By dividing by t, we were able to get an equation that was solved for vx, or the velocity, horizontal velocity the cars traveled. Knowing that x was equal to 13.93783 meters and that the time of flight was 2.6659411 seconds, we were able to plug in those two numbers, 13.93783 divided by the amount of time, 2.6659411 seconds, and get the horizontal velocity to be 5.228109362 meters per second.
Now we have to figure out the impact velocity upon the crash. Using the conservation of momentum, we know that the initial momentum is equal to the final momentum. Therefore, m1v1, the initial momentum, is equal to m12v12, the final momentum. Because Mr. Chuckrin's car was not moving, his momentum was 0, therefore that is negligible. M12 is equal to the mass of both the cars combined as they went over the cliff and landed, and that's equal to 2,716 kilograms. We know that the velocity of them going off the cliff is 5.228109,362 meters per second, and that the mass of Mr. Souza's car is 1,095 kilograms. Upon dividing M1, that's how we were able to figure out the velocity of the impact. So the velocity is equal to m12v12 over m1. Once we plugged in our numbers, we came out that the velocity of the impact on the crash was 12.96762,103 meters per second.
Finally, after finding the impact velocity upon the crash, it was time to find out the initial velocity that Souza was driving. Using the law of conservation of energy, we took the initial kinetic energy that he was using, and set it equal to the final amount of kinetic energy he had, plus the thermal energy that was created upon the skid. Using the equation 1/2 mv squared plus mg mu kd equals 1/2 mv prime squared. Solving for v prime, we got a general equation that v squared plus 2g mu kd to the 1/2 power was equal to the initial velocity Souza drove. After plugging in all of our known variables, we found out that Souza was traveling at a velocity of 15.79130,153 meters per second, which is equivalent to 35.324 miles per hour.
In conclusion, traveling 35 miles per hour on a road that requires that you only travel 20 miles an hour proves that Mr. Souza was indeed speeding when he hit Mr. Chuckrin. Therefore, Mr. Souza went to jail for the rest of his miserable life, and Mr. Chuckrin won this lawsuit and gained another $3.25 billion.